Switch on your microphones and introduce yourself. Excuse me. And then I'm going to use that as attendance. All right, and then also to get to know your name. So let's go. Let's start with Omari. What's your
Okay, sir. Good evening, sir. Or good afternoon, sorry.
You're not here, Ruben.
Hello.
Ruben.
Hello.
Sir.
Ruben.
So Omari is here.
Sir.
Augustine.
Yes, sir.
Hello.
Yeah, Omari, what's your full name?
Mario say as you do.
Index number.
ENJ 19B002021.
Okay, put it in the chat. Type it in the chat, okay? Everyone,
Okay.
all of you do the same. Go to the chat, type your name and index number. So that I'll just copy it.
All right, yeah.
So that's
Okay, that's fine.
I expect 1, 2, 3, 4 people. Excuse me. To write down their names. Use the same ID. So if your name is Omari, I don't want you to go and write a different name over there. All right, so use that same name.
Yes, sir.
Duhamel, Ruben, Augustine. All right, great. So let's go straight to business. This is an introductory lecture, so I'm going to introduce you to everything that we'll be talking about. All right, so pay attention. First lectures are the most important lectures. You are online, you are not face to face, so you should even pay more attention, otherwise you won't understand, okay, what I'm talking about. Okay, so geographic information systems, that is the actual course, okay, and we want to look at the application in civil engineering. So we want to understand what it is. Then once you get to know what it is, then we'll see how it is used and applied, okay, in certain scenarios, situations. Okay, so we're gonna start by just introduce you to basically why you need to use such a system. Okay, and we'll talk about what the system is about. Okay, so the first lecture is to just talk about what GIS is about. Like you said, J stands for geographic, I for information, and then S for system. Is that okay? So this is a kind of system that allows you to retrieve information. But the kind of information that you are retrieving is a geographical type of information. So the geographic there qualifies the information. In other words, what it means is that this information systems that we are talking about here, literally, except that the kind of information we're getting is about geographic objects, or let me just say about our geography, about our world, about the phenomenon on the surface of the earth. So that's the only thing that makes, GIS stands out from the other information systems, because we have MIS, we have management information systems. All these systems allow you to retrieve information, but they may not have geographical dimension to it. Even though the trend now is to add a geographic dimension to most data sets that have already been collected, which may not be geographic, non-geographic. Okay, so GIS is a very interesting topic. You don't have to make it complicated. Is that all right? Just keep it simple and you'll be just fine. All right. System, trying to retrieve information from it. Of course, you can't retrieve information if you didn't store that information. So it should allow for storage and for collection and for management of the data. And now you can now retrieve it. I keep saying that if something gets missing in your own room and you're the only one there, then you have just one problem. Are you okay? And the problem is that there is no order in your room. Are you okay? Looking for the socks, you can't find it. It means your room is disordered. Just rearrange everything, okay, and then you find it. Because you're just there alone by yourself. Are you okay? Am I talking to someone? Okay, so that is the whole thing about GIS. It gets, we go deeper than that. We just don't say this and say goodbye, class. We just finished talking about it. No. We want to get deeper and understand the nuances and the different aspects of it. Are you okay? Like I said, we're not going straight to apply it because you've not done any GIS before. So I want to just introduce you to some basic concepts and in the initial stages. One of the concepts that we will be looking at, and before we even talk about concepts, that we're looking at application areas in GIS are just interesting. It's not only civil engineering that you can apply GIS to. And our focus is to look at how we really apply it to civil engineering, but you'll be surprised to know that there are too many areas where, or so many areas where GIS applied, including the military, telecommunication, and all these places. We will talk about it a little bit more. We want to talk about in the introductory phase of this lecture, we want to look at some concepts, okay, some operations that we can do in GIS. And we are looking at something like layers and themes. Okay, so what are layers and themes in GIS? We want to keep data layered. We don't want to have data all over the place, bunched up together. We want to have data well grouped and arranged, yeah, well organized and well arranged as well. So we will deal with what we call layers. So when we say a layer or a theme, what are we talking about? You realize or recognize that information is not, you know, as simple as you think it is, or data itself is not. Of course, information derives from data, but data, especially in the age that we're in, we are in the big data age or era, where there's so much data that we are more worried about the analysis or understanding the trends in those data. Are you okay? Of course, that brings the topic of artificial intelligence into mind. But what point I'm trying to make is that there's so much information. There's so much information, but we need to know what we're doing with that. That is the main thing. Are you okay with layers and themes? So if we can group data into different themes, I don't want to say thematic areas, themes, topics. Themes are like topics. If we can do that, then we are making some progress. That means that we are more organized. And being organized with it means that we can do analysis based on that. It's just like constructing a building and putting the first floor plan, second floor plan, third floor plan, all into one sheet of paper. You can imagine the chaos. If you won't do that, then that's the reason you want to create layers. It's okay. Software like AutoCAD, okay, which is actually computer-aided design software, will allow you to create layers. But nobody really asks themselves the question, why do we create the layers? So we want to look at the way layers are created. And once you are creating layers, this is what you are doing. You are literally separating, you know, or the information data, you're separating it into different smaller chunks. Now, once you do that, then you need to think about bringing them back together. Okay. So overlay is what you do when you actually have so many layers, you overlay them. Okay, so naturally we'll be looking at overlay, different ways to overlay the different layers that we have. Okay, so that's one topic that we'll deal with. It's a concept. We'll talk about buffering. Okay, so buffering is an interesting concept that we need to look at. Why? Because naturally we want to constrain the space around geographic features. Is that okay? We want to constrain space around geographic features. Now, constraining space around an object is more mathematical than, you know, the way I'm making it sound, if you understand what I'm saying. Like, we are talking about equidistance. Are you okay? Creating a certain or drawing a line or a boundary around an object in such a way that all the points that define that line are equidistant from that object. That is a circle. What I just said is a circle. And how to define such a circle? By the distance, the equidistance. And so you end up with a circle with radius equal to that equidistance, which we want to call the buffer distance. Is something we want to talk about in this class. We want to show how that affects some of the things that we do out there. A lot of things that engineers do require that a certain space is or gap, okay, is created, but you just don't give it an arbitrary value, and it has to be a constant value. And when you do that, that is the concept of buffering. You're referring to the concept of buffering. So we'll be looking at the different types of buffering, point buffers, line buffers, polygonal buffers, and we look at how these are applied in the real world, in the proper, setting. Are you okay? Working, and then there's a need to create a buffer. How are you going to do that? At the end of the day, every engineer wants to go out and then set out something, want to break some things just to build other structures, want to break structures to put up structures. Okay, there are safety considerations. All that require that you may want it, no, you may, but you have to create a buffer or space around a feature. One of the important things to look at in the workplace and the construction site, wherever you are working, is making sure that you don't collect information and give it to the computer. Are you okay? And the computer misinterprets it. Excuse me, that's analysis on the data you're giving the computer. Because the computer is that stupid that is what you tell it to do is what it does. Are you okay? All right. So in the same vein, there are functions that have been created to correct for the errors that may be created. But even then, human errors, there's so much you can do about it. Someone is crazy, there's not much you can do about it. Are you okay? They're going to make mistakes. Yeah, just going to make a mistake. There's nothing you can do about it. Of course, what we can do is that we can just fire them. Are you okay? If they work in our organization and I employ you after your degree and maybe you just messed up, just get fired. End of story. Goodbye, Charlie. Are you okay? But the point being made is that we should try as much as possible to reduce the errors. So typical example is you want to tell the computer that there's a T-junction, all right? Well, the T-junction is being represented by two intersecting lines, or there's a crossover, and or whatever, what they call it, the interchange. Are you okay? People say interchange, Caswell interchange, whatever you want to call it. Is that okay? So you want to make sure that you don't give the computer the wrong info Otherwise, you're going to have the wrong output. Is that okay? You want to sit over there if you are part of this. Are you part of this? Please sit on that side so that you can face me. Yes, so please and keep an attendance list for me, okay? For those who come. Make sure that you take off the errors, and one way of doing that is letting the computer figure out, of course, these errors. But how good is that? I mean, if a computer has to figure out that this line is supposed to reach this and it's not, you have to simply say to the computer that if a line is this distance away, the end of a line is a certain distance from another, then I want you to snap to it. So that correction is, you know, part of what we call topology, which is really about the relationship between geographic features. Okay, well, where were you? Where have you been? You didn't know that class was here? 1:30. I was here 1:30. The class is 1:30, so we have to be here 1:30. Okay, so I'm still, this is an introductory class, so try and follow, okay?
Are you sure it's?
You are here, so what do you want? But you can also follow. It's on Zoom.
I'm not sure you are sharing from the mind.
No, definitely you can watch it. Just watch it, okay? Because I'm sharing my screen. Yes, I am. There are people online. Don't forget that. So they have to see what I'm talking about. So you just go there. Something you have to watch. You watch. If you want to ask a question, I'm here. Okay. Right. In fact, there's even no board here, so just use that. Okay, so that is basically it. You need to make sure that data that goes into the computer is topologically correct. So we'll be talking about the concept of topology. So there are different types. What I was describing is more like what we call it, you know, connectivity. Are you okay? There are different types of topological rules. So connectivity, we have containment, we'll be talking about all of them. Okay, I'm just going about things we'll be talking about. But if you are smart, let me just say that you can just understand everything today, and then, but you have to still come for the lecture. Is that okay? Or if you do, I'll give you 0 for not coming. All right, so topology is a concept that needs to be discussed. It's very, very important. One of the things that we'll be talking about is data acquisition. So data acquisition, that means acquiring data, get data. How do you acquire data? How do you collect data? Are you okay? Literally what it means is that you are not dealing with data that is already existing. You are not talking about secondary data. You are dealing with primary data collection. You're not buying the data with some dollars. Are you okay? You are simply going out there and you're collecting it. We want to know the different data collection methods that are used in GIS. So we'll look at land surveying. I won't talk much about it. We just touch on it because most of you know this. You've been taught introductory to land surveying. In fact, most of these, you have met them before. There is what we call photogrammetry. So photogrammetry is actually using aeroplane, okay, and then flying over an area, and then you get photographs, and the photogrammetrist simply works on that, analyzes it, and he's able to generate 3D model of the ground. So the question is, how do you relate that to what the land surveyor is doing? What the land surveyor is doing is that he's just collecting coordinates, making use of measurement of distances and angles. What the photogrammetrist is doing is that he's just getting a picture of the ground, and then he's only going to extract that information from the pictures. So he doesn't need to go down measuring backside, foresight. He doesn't have to do all that laborious work. So it's more or less a smarter way of measuring, okay, from the objects within our environments, okay, within our project sites. Okay, so it's important that we get to know how this works so that we know how to use it. Okay, we will talk about GPS. So GPS actually stands for Global Positioning Systems. So Global Positioning Systems. Okay. So Global Positioning Systems means a globe everywhere you are. People just don't write words because they just want to say global, they just put it there. What he's saying is that everywhere you are on the globe, I can get you your position. So everywhere you are, you can track your position. That is how serious it is. Are you okay? So I can be on the sea, it's raining, there's a storm, but all I need to do is to just do an SOS and just say that, hello, 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 SOS, SOS, my position is 6 point, blah, 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 blah. And maybe the US Navy or something will just come and get you. You see how important GPS is? Because if it wasn't for that, this is the way you're going to get out of there. You're just going to sink. Are you okay? You're just going to sink and you just sing some hymns and just go now. Excuse me, it's not funny. But global positioning systems are powerful, that powerful that the US Department of Defense came out with it so many years back, and then they didn't even want civilians like you and I to use it. But today, we are holding a smartphone and we have what we call location on it. And that location is GPS, Global Positioning System. It's similar to the one that a surveyor will use for satellite surveying. So we can use the traditional land surveying techniques where total stations are used, but we can also use global positioning systems. So we will explain what goes into it. Are you okay? We go a little further into it, but let me just say that I will be saying more than I'm saying now. Just repeat some of the things I just said, add a little bit more to it, and we all say goodbye. So GPS is come to stay. It's one of the tools that you see a lot of people using, one of the equipment a lot of people use today for all sort of work, for engineering work, for whatever you want to use it for, fishing, whatever you want to use it for, crime and all that. But of course, for us engineers, we are getting our coordinates from the GPS. Now, straight away, you can see that photogrammetry will give you a set of photographs, okay? And of course, to generate a model, a 3D model, and then the land surveying also give you a set of coordinates. Are you okay? And these coordinates are coming from the distances you measure, the angles you measure. Are you following that? Okay, so now I'm talking to you, okay? Now they can just check on me because I didn't know you were here. Now, land surveying will give you coordinates because you have distance, you have a bearing, and you can calculate coordinates. We all know this. All right. Now, GPS too will do some sort of resection. Okay. The satellites will track, get your location. All right. Photogrammetry, looking photographs. So what's the difference? So it means that two different things you're getting. Are you okay? One of them is giving you coordinates, a lot of it, plenty, everywhere. If you're working here in this area, you're getting the coordinates. So there are points, a lot of them. Photogrammetry is saying, I'm giving you a photograph. Extract your information from it. Are you okay? All right. So that is the basic difference. We will touch on remote sensing. Okay. Now, remote sensing makes use of satellites, but we are looking at just one satellite. And that one satellite is now scanning the ground. It's also giving you imagery. So here I'm not saying photograph. It's giving you imagery. Because what we call photograph limits us to light. Are you okay? visible light. Now, visible light is photo. That's what we are used to. When we say imagery, it means that we just don't want to say we are using light, because we could be measured from a different aspect of the electromagnetic spectrum. So it's as if I'm taking a picture of you now, but I don't need the sun. Are you okay? So, okay, it's night. Let's be here. You know, if it's night, this place is going to be very dark, right? But if the kind of camera I'm using, all right, is not measuring using this light, and it's using another, you know, sensor, which is sensing your body heat, I'll get an image of you. Are you okay? Because everything around you will be cold, except you. You have a body temperature, and that will be measured. Okay, so the fundamental thing for all of you is to start revising things like electromagnetic spectrum, which means that I always give this example. You have our old, those who were born maybe before computers, and then they go to hospital, and then the doctor says, go and take an x-ray. What the old person will tell you is that, oh, the doctor told me to go and take a photograph. Okay, because that's the best way to explain to you that you are going to just get an imagery of your bone and all that, because who takes a picture and then you get to your bones? Are you okay? Can you imagine if someone took a picture of you, shakes you, and it's just your bones? Are you okay? It's going to be scary, isn't it? But basically, remote sensing goes beyond the visible region of the electromagnetic spectrum. But we're able to take advantage of that and then to measure what we call spectra from objects. In other words, we're able to obtain more information from the objects than you could do with just the normal sunlight. Okay, but what we should tell you is that the satellite then has a camera or sensor. So the camera is a sensor. In the photogrammetry, it's a camera, literally. In remote sensing, we don't want to say camera, we say sensor, because the two are similar. The camera is a sensor, but not every camera, every sensor is a camera per se, but they all behave the same way. Are you okay? We measure from different aspects of the electromagnetic spectrum. So we'll be talking more about this when we get to this place. But with this introductory lecture, the idea is to whip your appetite, okay? So that when we get there, you can even ask questions, all right? We have 10 minutes for those who are online. Please rejoin if the line, it cuts, not the line, this one is not a line. If the Zoom session ends, are you okay? Because of COVID, we've all learned a lot, isn't it? Realize that people know what we call a session. Session is something that we should have been people who are experts in web applications development here and stuff that should be talking about that. So this session, when it ends, please rejoin. All right, so we're going to talk about remote sensing. All right. We will deal with secondary data. If someone gave you data that already exists, existing data, okay? What do you want to do? You want to understand the different formats. Are you okay? You need to understand a popular format called a shapefile. We will talk about that. All right. So this is important for you. You need to also understand what we call metadata. So this is where metadata really should be taught, but maybe I may teach it a bit earlier. So metadata. So metadata allows you to know how data about data. Is that okay? In other words, I will send you some data on the project that we are going to do. Is that okay? Then when I send it, I'll add a small file. That will be the metadata. So that small file will tell you about the data I've just sent you. So you don't have to call me and ask me questions. Oh, so that the data you have doesn't reach this. What's the extent of the data? Are you okay? And where did you get this data from? All that will be in the metadata. Is that okay? So we learn, when we get here, we talk about the different sections of the metadata. Is all right? Okay, so as an introductory lecture, try to even understand the introductory lecture. When we get there, you won't go like, what is he talking about? Please, this lecture is as important as the lectures that we'll have subsequently. All right, because what if you get there and you just don't understand it? So even in this lecture, try to make your own notes and follow. It's very good. Introductory lectures are very good. All right. So we talk about metadata and understand the different sections of the metadata. Then we'll talk about data models. Data models, or if you like, data structure. Data structures. Okay, here, this is the idea. It's nothing complicated. We want you to know that the difference between GIS and AutoCAD, for example, that's computer-aided model, is the fact that computer-aided design software or computer-aided design doesn't incorporate, is now they are trying to integrate some of the principles in GIS into it, but the data model really makes GIS stand out. Otherwise, you realize that, oh, everything we are talking about in GIS is really like CAD, okay? But it's not. You realize that we are able to deal with vector data, the vector model, vector data, vector model, of course. Then we can also deal with our raster model. We want to talk about these models. What do we mean by vector model, raster model? What is the model? Very simple. A model is just a representation of the real thing. Okay, right. So if we have people who model a dress, a design, what do? They try to show you that when you wear it, this is how you look like, right? But you know yourself, you know you're not that type. Are you okay? So that is where the challenge is anyway. So the vector model is about points, lines, and polygons. Okay, whilst the raster model is about pixels. Simply put, I want you to do an exercise, all of you. So this is an assignment. Submit the assignment wherever you can do it. Are you okay? You can put it on Google Classroom, or are you okay? Or maybe I have to create it there for you, but do it, even if I don't ask you for it. So your own house, try to represent your house with just squares only. Okay, your own house, where you live, that small place, and try to represent it with lines, points, and polygons, and then you can show it to me. Is that okay? Normally, when I give you an assignment and I'm not demanding for it, it's not good for you because it can become an exam question. Is that okay? But if I even demand for it, then it may not come. Anyway, I'm not saying it's an exam question. I'm just saying. Right. So our world can be represented by squares. How? We literally say we can represent our world by just pictures only, because every picture is made up of just smaller squares. Okay. So if you take a picture, go closer to it, you find out that it's just squares. All right. Now, why is that? Why do we have that? We have that because the actual sensitive material that's recording, all right, the scene or the project area is divided into what? Squares. Okay, and it's now recording from the objects. Okay, so like I'm covering you with squares, And then I say, okay, I see blue, I see white, I get that. So I cover you with squares. Just picture it. You see that it's possible, isn't it? And that is what happens when I put my phone on you and I switch it on. Are you okay? We'll talk more about this. If you don't understand it now, don't worry. If you understand it now, it means you get an A plus or something going for it. But hey, GIS is not, it's easy, but it can be difficult. It depends on how you take it. All right, so please pay attention. We can represent our world with just pixels, pictures, and we can also make use of lines, points, and polygons. Very easy stuff. We'll be talking about this data model. Are you okay? All right. Then one of the things that we'll talk about that is very important is what we call the, what do you call it? Coordinate systems. I think the food wasn't enough. Yes, we're going to talk about coordinate systems, map projections, sorry. Map projections and georeferencing, more or less. I mean, map projections and georeferencing, they are together. In fact, to georeference is just give some kind of code. Are you okay? That can help me to locate something. All right, so I'm not even talking about geocoding here. I'm talking about just being able to locate something. That's georeference. I can reference something, you can put numbers. You see a lot of companies, when you go in there, you see that the furniture has been numbered. So I'm sure maybe AIT also does the same thing. So if you have a chair, there'll be a number on it. You see AIT 12K11. All they are trying to say is that this property is for AIT. I would mean it's been referenced. Now, if you show reference, that means that you will get to know exactly where that thing is. Okay. All right, but of course, this is in the computer. This exists in the computer. What's the computer? Map projection. Okay, what is map projection about? What is it all about? When you project, what you are saying, I'm going to teach you the concept of map projection. What you are literally saying is that the world isn't what? Flat. But that the world is actually what? Round. Okay? You're not watching the screen, are you? You're watching it. Okay. So watch it again. So you see that the world is not what? Flat like a pancake, but it is what?